So we will be covering Project Lambda. That's very interesting. And if you are wondering who is this guy, why he's talking about technical stuff here, let's say I have some backgrounds. I have, let's say, open source. I'm open source committer, few certifications. I'm technical reviewer. Works on some interesting companies. Currently, I'm working at Barclays. And the reason why I'm talking about Project Lambda or the functional movement in the Java world is because I'm investigating the whole scene over the years. And just before we start, I found one very interesting quotation. I think it would be very interesting to start with. Mostly when you see programmers, they aren't doing anything. One of the attractive things about programmers is that you cannot tell whether or not they are working simply by looking at them. Very often they're sitting there seemingly drinking coffee and gossiping or just staring into space. What a programmer is trying to get a handle on all the individual and unrelated ideas that are scampering around in his head. So our job with Tomáš together during the next 2 hours will be just to cover and answer all your questions you might have related to functional programming. Now, to get to the point, we have a lot of things, and initially this talk was scheduled for 1.5 hours because I have to shorten it in a half. We might skip some sections. The idea is to go first through the reasons to introduce Lambda expressions, because that's the first thing you might ask. Why do we care after 17 years to add functional concepts into a language that is already mature? Then naturally, if we know the reason, it will be good to talk a little bit about Lambda expressions, and specifically comparing to closures. A lot of people just mix the definitions and they are not technically correct. It will be not the full story without saying anything about history. There were historically 3 very strong proposals, and the Project Lambda was shaped on the basis of all of them. So we learned everything, or we learned a lot of stuff from every one of those, and there were more of them. And then we'll, most of the time we'll focus on Project Lambda, mostly from a syntactic and semantics point of view. So we'll cover Lambda expressions, very quickly function types, functional interfaces, target typing, lexical scoping, captioning variables, all the horrible theoretical aspects we will cover in a practical meaning. And if we will have time, we will cover the default and static interface methods. And streaming API and meta references will be what Tomáš will be covering. Okay, so the first thing that you might be asking yourself is, why are we introducing Lambda expressions after 17 years? And there are people that are saying that we are not able to program in a functional way in a Java language. That's not correct, simply because we have anonymous inner classes. But one of the most important reasons is to address concurrency more efficiently. And Doug Lee, which is the core guy after Java util concurrent package, a lot of abstractions out there, he was one of the most important guys in the Java community, and he basically said that if we will be not more effectively able to handle or to pass code as data in the Java language, the concurrency will never be solved in a normal way. As an example, function framework Java 7 introduces abstractions that allow you to decompose the problem, but the idea is that you are passing the code, small pieces of code. And using current syntax like anonymous inner classes is a very bad idea. And we'll be talking about this a little bit later. Other reason is to be more functional friendly, because immutability and the ability to model problems in an immutable way is the future. The Scala and other languages are heavily based on that foundations, and also the streaming abstraction. As I said, to be able to model code as data, and the idea is that you should be very easily able to pass code as an argument to a function, or return it as a value of a function. So we are effectively talking about higher order functions, if you are familiar with the functional programming. And there are a lot of practical reasons why anonymous inner classes have kind of problems. Starting with bulky syntax, you have to write 5 lines of code where most of them doesn't make any sense, and only one is actually important. It's the code that will be evaluated. There is a confusion surrounding the meaning of names and this, because they're adding lexical context. And this, in terms of anonymous inner class, points to the anonymous inner class itself, which is kind of surprising for some of the developers. Another problem is that we have inflexible class loading and instance creation semantics. There are some very obscure situations where you might be causing out-of-memory leaks just because of using anonymous in your classes. Inability to capture non-final local variables, and inability to abstract over control flow. Now what that last means is that you are not able to use non-local returns, for example. The point of a project Lambda in the Java world is not to solve all of those problems. They effectively solved the first three ones. We'll be talking about all of them. The fourth one was solved by not solving it and by providing kind of a hack. And the fifth one was never point. And I do think that that will be a mistake to introduce that feature or not that feature in the Java language. And it's finally about the time. We have to switch into functional programming mindset, all of us. Okay, so if we do agree that it will be a very good idea to introduce Lambda expressions, the first thing that you would ask is so what is the Lambda expression? And the formal definition is, it's also sometimes called Lambda function, function literal, function constant. The definition is that it's an anonymous function defined and possibly called without being bound to an identifier. What it means is, so it is a function like any other method in the Java language. It might return something, so it has a return type. It's anonymous, that means that it doesn't have a name. So you have to have a model, execution model that defines how the Lambda expression will be called and evaluated. It might take arguments because that's a natural thing. And because we are in the Java world, it might throw check exceptions. So it's like any other function or method, it just doesn't have a name. And it originated in Lambda calculus by Alonzo Church, which is, he basically created the foundations for functional programming. Now many people would not agree with me here, but Lambda expressions are not closures, and most of the definitions I found are just mixing the definitions. The difference between closures and Lambda expressions is that closures close over its arguments and they are executing in the current execution context. That's a very theoretical one, and if you would have time, I would just explain it to you directly what it means. Quickly speaking, we don't have closures in the Java programming language. We do have Lambda expressions, or we will have in Java 8. And as I said, I created this talk to be kind of practical. Just showing you an examples of syntax and semantics doesn't give you the full story. And it will be actually a fail from myself. So we have to cover all the reasoning, and not cover history will be a big fail. So everything started in 2006 on the DevOps conference. There were three main proposals filled just after Java 6 was released. And we will very quickly cover all of them. So there was the BGGA that was led by big names. Gal Braga, that's the co-author of the Java language specification. Neil Gapter, that's the guy after generics. And he implemented it in Java 1.4. And yes, it was implemented in Java 1.4. It was just turned off by default in the compiler and officially introduced in Java 5. James Gosling, the author of the Java programming language. So big names, the guys that know a lot about language design. The problem with that proposal was that it was too heavyweight. They were trying to introduce non-local returns and function types and a lot of features that just doesn't really fit into the language. On the other side of the barricade, it was the size proposal. That was led by George Bloch. George Bloch is the chief Java architect at Google. He's famous because of his Java Puzzler talks. And what he was trying to do is to provide exactly opposite side. So don't do any kind of crazy function types, any language features. The only point was just to create a syntactic sugar over anonymous inner classes. So all the restrictions that we have, all the execution model that applies will still apply. You will just be able to write a shorter syntax. And somewhere in between was the FCM. So they were not as featureful as BGGA and not as small as size. So they were introducing method references, for example, but not function types. And if we should compare the project Lambda, it would be probably, well, most likely the most similar to FCM. It's not the same one, but from a features perspective, it's kind of the FCM. What is important and what we learned and what Java world learned from those three is that we cannot be as heavyweight as BGGA, we are not introducing function types because it will be recipe for disaster. It's just a very bad idea. We cannot be as easy as size because just providing syntactic sugar is not solving the whole story. And without retrofitting other language features and core APIs, it will be not that useful. So something in between. And all of them have failed. This is important. In 2006, people were not ready for functional programming. And I think a majority of people are still not ready for functional programming. But at that point, it was not really obvious what do we want to achieve with concurrency, what do we want to achieve from language design. And now it's much more obvious. We don't have VM support, which was kind of past. So now very boring stuff. If you would like to find some documentation, Project Lambda formally is JSR 335. Part of the Java SE8 consists of a lot of things we will just cover. So if we agree that, because I just said, that Lambda expressions are anonymous functions, so no problem. One of the design decisions they made was to solve so-called vertical problem. So if you are creating an anonymous inner class, you have to define a new instance of anonymous inner class, curly braces, then possibly the override annotation, then the name of the method, curly braces, and then that's the finally one line of code that actually matters. It's called a vertical problem, and one of the design decisions they made was to address that problem. So not be forced to write 5 lines of code, but possibly 1 or less. From that perspective, it should be kind of easy to get a syntax. And if we said that Lambda expressions are just like anonymous functions, so they don't have name. You don't see any name in that grammar description. There are normal braces. They are not optional because you have to distinguish on a compiler from a parser perspective that this is a Lambda expression. There is an optional argument list. As we said, you might be taking some arguments. There is an arrow, which is similar in some languages and different in the others. And another decision they made was that because we're talking Lambda expressions, expression in the Java programming language is something very small. Expression is something that is evaluated to a value. The problem is that in more sophisticated languages like Scala and others, much more things are actually expressions. For loops in Scala are expressions. If statements are expressions. So you are pretty much flexible in creating expressions because you can just put a lot of code there. If we will be allowed only to use expressions in the Java programming language, it will be very almost kind of useless. You would just be able to use very simple expressions. So that's the reason why we have to represent code blocks. If you would like to put more statements, that's a normal syntax. So curly braces and code blocks. This is how the Lambda expressions looks like. So in very easy example, Lambda expressions could be like this. That would be kind of hello world. And let's say for the sake of being that this is a valid Lambda expression. It is valid, but there is a trick. The first thing you might ask is, well, we are talking about statically typed programming language. We are in the Java world. Everything has to have its type. So what will be the type of that expression, right? We have Lambda expressions. And in many languages, if we do agree that Lambda expressions are functions, the type of a Lambda expression will be surprisingly a function type. And function types, there are examples in other languages. Usually you just want to say, you don't care about the name because it doesn't have a name. You don't care about name of the arguments. You're just saying that I'm taking 2 ints and I'm producing a Boolean. That will be probably kind of predicate, not really predicate because predicate would just take 1 argument and produce a Boolean. There are different language concepts in C#. They're called delegates that do a very similar thing. So on the type system hierarchy, we could represent them as a function type. The surprising thing is that we don't have function types in the Java language. And there are very good reasons why language designers decided not to do function types. And I will be spending 10 minutes talking about function types. Even if you might be asking yourself, this guy must be a little bit crazy. He's talking about language features we don't have. But the reason is, not adding language features could be actually a language feature. That's what George Bloch said on one of his great talks. And just to be a little bit clear why we don't have function types, because they would just make everything too complicated, too complex, too much work on everyone's side with getting almost zero value. It will be bad for all of us, developers, the users of the APIs, developers, because the method dispatch is already quite complex. And majority of people do think they know how to override and overload the method. I don't think that this is the case. I am pretty able to find an example to trick probably most of you if you don't read the Java language spec. Because we have covariant returns from Java 5, because we have historically widening, and in Java 5 we have boxing and varargs, and they could be matched together. And because overloading is that at compile time, but overriding at runtime, and because we have checked exceptions, and you could use all of them, none of them, any subset of them. Any of them could be more specific, but not more general. And this is the just tip of the iceberg. The method dispatch is really complex. Determining which method will actually be called in everything but super trivial examples is tricky. And everything which I just said would directly applies to function types. So it will be another point of failure, let's say. And we can divide developers kind of touching the JVM or Java into three parts. One of the majority of parts are us, we are developers. There are the API designers that are creating libraries, frameworks, and piece of code that everybody is programming against. And they would have a big problem. What we learned from a C# world was that once they added delegate, the notion of function types, it divided the world into two parts. One using the old kind of APIs, using trades, abstract classes, anonymous inner classes, enums, whatever your language provides. And the new ones using function types. The problem is that they are fundamentally different, and you can't just cast one instance to the other. They are just different. So you need to maintain two versions of APIs with getting almost zero value. The most critical part is because JVM is not ready. Function types would be most likely the huge effort. This is kind of speculation because we don't have function types. But there are a lot of things that would need to be enhanced, like type signatures, bytecode for verification and invocation. Every time you load a bytecode, you need to verify whether it's not kind of corrupted. And also the most complicated part would be probably the invocation model. So we historically have 4 bytecode instructions. We still have invoke static, invoke virtual, invoke interface, invoke special. Starting from Java 7, we have invoke dynamic. None of them really fits into function types. So to just recapitulate, nobody will be happy by adding function types, so we should be happy that we don't have them. And I have to say this. Now, if we just said that we would have Lambda expressions, and the natural representation would be function types, and we also have that we don't have function types, and we are in statically typed programming language, we have a mental problem, because we can't have Lambda expressions in the language, unless there would be something that is already existing on a type system, from a type system perspective, something that was meant to be a contract, something that is there for many, many years. And I'm pretty sure that most of you are guessing that yes, we are talking about interfaces. So from a type system perspective, once you have a function or Lambda expression, it will be represented as something that pretends to be an interface. I would like to say it in this way. The natural question would be, what kind of interfaces are we talking about? Like, can you associate any kind of interface with any kind of Lambda expressions you might imagine? And I would answer that by asking you a question. If we imagine a situation that we have a block of code, at the beginning we were talking that one of the most important parts why we should include Lambda expressions is to be able to express code as data. So we have like code block, and we would like to associate it as part of the Lambda expression. If you would have an interface with 10 methods, returning different types, taking different arguments, throwing different exceptions, how can you possibly know which one to associate with the code you would like to associate it with? The very simple answer is you just can't. And that is the reason why they introduced a thing called functional interfaces. They were previously called sum types, which was abbreviation for single abstract method types, which is no longer kind of really descriptive. And the reasons will be talked a little bit later. Very simply speaking, functional interface is an interface with just a single method. And even if that might be like, you might be smiling because I see some smiles on your faces. This is a very important definition because, okay, I forget to add the abstract, but the abstract is the most important part. Historically, up to Java 8, every method that was declared as part of the interface was abstract by default, and you could only create abstract methods as part of interfaces. This is no longer the case. Rules of API design are just changing as part of Java 8. And the very important point is that compiler could identify interfaces based on its structure. What it means is that they added a functional interface annotation. All the core APIs were retrofitted to use that annotation, and compiler is actually able to check whether your interface has only a single abstract method. This is important because you might be using functions and Lambda expressions in the Java program language, and if anyone would like to add a new method into a functional interface, that would cause your program not to compile, because compiler would not be able to transform the Lambda expression into an instance of an interface. That's the reason. So you are kind of safe by annotating them by a functional interface. There are a lot of examples. If you're asking, so what might be the functional interface? One of the most important ones and famous is runnable or callable. If you have ever used Java util concurrent package or thread pools or threads callables, you know what it is. Runnable has just a single method, takes nothing, returns nothing, throws nothing. Callable returns something, takes nothing, throws nothing. There are examples of the others: comparators, action listeners from Swing library. And there is addition of new ones. It is important that, as I said, just adding a language feature by itself is not that useful. Without retrofitting the core APIs, without changing them, without adding other language features, they actually make sense to make them more productive and useful. It will be kind of useless to add Lambda expressions. In the same way as adding for each loops without generics would not be that good fit, just adding Lambda expressions without adding some new functional interfaces would not be that useful. So examples might be like predicate, that's something that takes a T and returns Boolean. You might use it for filtering. Consumer is just consume stuff, right? We are consumers. So it takes T, returns nothing. Function is like a mathematical definition. It takes T, returns R. Supplier is like a factory. It takes nothing, just returns a T. And there are operators. So operator applies an operation on a T and returns T, or binary and two arguments. Okay. Yes. So we know that we have Lambda expressions. This is kind of a valid syntax. This is a valid syntax for Lambda expressions, but for some reason it will not compile. That's the reason why I'm not opening NetBeans or other IDEs, because it will just show you that this is not compilable. And the reason for this is, and if you might be asking how the compiler actually transforms that code into an instance of an interface. It's not really, not necessarily, to be technically correct. It doesn't have to create an anonymous inner class. It's not. It doesn't have to generate other stuff. So there have to be a process of transformation. And if we would ask specifically what's the type of that Lambda expression, well, the problem is that I don't know. And that's not really a problem because none of you can know and nobody knows. Even the compiler don't know. And the reason for this is because the type of Lambda expression always depends on the current context. So you can't say this is of type runnable, even if it might be. It takes nothing, it returns nothing, right? System out print line. It shows no exceptions. It might be able to associate it with runnable, but it's not of type runnable because it depends on the context. That is the reason why this would cause compilation error. Another example that would not work, it might be surprising, is this one. If we would do exactly the same, and let's say that this really is a valid syntax for Lambda expression, you can associate it into an object. The reason for this is a thing called target typing. That's a technique of the compiler that just determines the type of Lambda expression. And what the compiler is trying to do is it will look at this expression and it will know that this Lambda expression, because this is color braces and it has an arrow, and there might be an expression or code block. But it has to compile it somehow, so it has to know the type. So it will look on the left side of the assignment operation, and we'll look that this is an object. But wait a second, we just said that the type of Lambda expression is a functional interface. Object is not really a functional interface because it has more than one method. An object could never be a functional interface because it's not an interface. So that is the reason why this is not allowed. This is forbidden by the compiler because it can't know which method are you associating the system out print line with. It might be equals hash code and others, but this doesn't make any sense. So what is the valid syntax finally is this one. You might be able to, you are able to associate a Lambda expression into a runnable because runnable conforms to the syntax of a Lambda expression. It doesn't take any arguments, it has just a run method, it doesn't throw any exceptions, and it returns nothing. The way how you would invoke this, and this is important, is by calling a run method. What is important to say here is, this is not a general solution. You are not able to allow to call every Lambda expression by calling a run. This is just a coincidence here. So because we have an instance of runnable, and because we said that this code will be associated with the run method, that is the reason why you are able to call a run method. If you would have a callable, you would call callable by calling a call method, action listener by action performed. So the run is not because of any Lambda expression would have run, but because run is defined in a runnable interface. One of the important points here was, again, a design goal, which is called don't turn vertical problem into horizontal problem. And in terms of callables, okay, let's skip this. You are able to define arguments. What you are able to do is to define a Lambda expression that takes a string of type S and returns a code block which just returns an S. It is kind of useless Lambda expression. It just takes something and just directly returns it. But to explain the design goal, not to turn a vertical problem into a horizontal problem, we should be able, and the design decision was to be as syntactically short as possible. So you don't really care about the string type here because compiler could infer it. And it is inferred by the target typing. That's one of the reasons why they have introduced target typing, to be able to remove a type. That doesn't mean that it's dynamic. We are still statically typed. It just means that the type, okay. I would need to have an interface that takes, let's put it, interface, all right. So the valid syntax is this one. What the compiler sees here is that because you're inferring into an I type, and because E is an interface, it knows that there is just a single method, M, that returns a string and takes a string, and that's the reason why it knows that the as has to be string. So it will check whether, if you do any kind of computation on as, like asking for length or a character at current index, it will just check everything. Also, what is possible, not just to remove the type, also remove the returns. And the shortest syntax you could actually write is this one. If you have just a simple expression that just returns, you don't have to put a call block and also the returns. So that's the very short syntax, and that was one of the advantages of using anonymous, Lambda expressions over anonymous inner classes. And just for language geeks, this is called poly expressions. Poly expressions were added in Java 7, kind of formally. An example would be a diamond operator. So this is an expression which type depends on the current context. If you are creating an array list of type that is not defined in the braces, it will be inferred from a type. And that's very similar for Lambda expressions. Okay, we have just two other language concepts to kind of fully cover this. And one of the disadvantages of using anonymous inner classes was that they have defined their own meaning of these and names. What it means is that this always referred in anonymous inner classes into the anonymous inner class itself, the instance of anonymous inner class. That might be surprising, it might be looked at as a feature, but it's not really a feature. It caused a little bit of confusion. Also, inherited members in inner classes can shadow outer declarations. What it means is that if you would have a class that defines a toString method, and you would try to call it from within an anonymous inner class, you would be actually calling the toString from an anonymous inner class, because it is shadowing this to point to the instance. And Lambda expressions do not inherit any names from its supertype. The important thing here is that they do not define their own level of scoping. This is kind of for the first time in the kind of Java world where we have this. What it means is that this doesn't have a special meaning. And if I would have a Lambda expression that would print this, that this by itself refers to the place where the Lambda expression was defined. What it means is that it has to be defined, or it can only be called from a non-static method, because this will refer to the class itself. And this is also the difference when I say in the beginning the difference between closures and Lambda expressions, because they are referring to the meaning of names is defined in the context of definition, not at the context of runtime execution. Okay. Now, you might be thinking that anonymous inner classes suck and Lambda expressions are amazing, so let's just use Lambda expressions all the time. This is not the case, because there are very few examples where you would really still need anonymous inner classes. Specifically, if you have a computation problem that you would like to pass into a thread, for example, and it's a little bit more complicated, it's just very natural to decompose the problem into multiple functions. And so you would define helper functions. You are able to do it in anonymous inner classes, even if majority of people don't use it at all. You're not able to do it in Lambda expression simply because Lambda expression is a kind of a body of a function. You are not able to define more of them and associate. It doesn't make any sense. This is one of the very few examples where it still makes sense to use anonymous inner classes from Java 8. The last point, and that was the 4th point in the beginning where I said that there is restrictions of the anonymous inner classes that they don't really solve, but they solve it by using a hack. In anonymous inner classes, you are able to so-called access variables, and you're able to access local variables only if they are final. There are reasons why this is implemented in such a way, simply because Java Virtual Machine is a stack-based VM. And local variables are defined in a current execution frame. So there might be a situation where anonymous inner class was created. It was passed to a runnable somewhere in a background thread. And from that perspective, the initial class was just garbage collected, and the anonymous inner class could still exist. But at that point, the local variables no longer exist because they were just popped out of the frame. So there are technical challenges why this is really important. And they introduced an interesting hack called effectively final variables. So they are solving the problem of having to define a final variables but not solving it by forcing a compiler to put a final keyword by default everywhere where you are assigned, where you would like to access the variables. So they are not really changing anything. The only difference is that every local variable that you are accessing doesn't have to be declared as final, but the compiler will do it for you. And it also means if you are mutating it, like if there's a reference, you are assigning something new, or you have a primitive type, it will just not force you not to compile it. So that's not really solving the problem. It's kind of a hack by not solving it. Yes, lambda expression close over values, not variables. This is what we saw before. One of the implications, and this is important for pretty much any developer, every time you use an anonymous in your class, you might be actually causing a memory leak. And this is something surprising, but this comes out of the restrictions we have. It is defined in the Java language specification, and it has to be, because every time you are pointing to a field, it has to know the value, and the value could only be known, and it's only guaranteed to not garbage collect the class or object if there is a strong reference. That's the reason why, by default, every anonymous in your class has a strong reference to an enclosing object. So you might be causing memory leaks just because of creating anonymous inner classes, which is surprising. And the one thing they do better in terms of lambda expressions is that this still has to be the case where you really are using such variables. If you are not using variables, there's no reason why there has to be the reference. And this is really how it's implemented. So if you are not using any variables, it will not store the reference, and you might use a little bit less memory and don't get out of memory exceptions, which is kind of nice. And it's also kind of beneficial. It was highly respected by big guys from the Java community, just because using finals or effectively finals is kind of programming against functional style of programming, even if this doesn't guarantee immutability. It just guarantees that you can't change the reference, but you can still change the object. Yes, and we still have time, which is amazing, for default and static interface methods. So we covered the lambda expressions, so we know what is the syntax, kind of. We know what is the target typing. So you are able, or you have to associate or pass a lambda expression as part of the argument, or return it as a value from a function. And there always have to be the information for the type. So this is not valid, this is not valid. And the compiler technique to determine the type is called target typing. And it is way more than just a kind of, I would say, stupid substitution, because it might infer types and check whether everything is okay. And we talk about lexical scoping, so there are very small, subtle, like semantic differences, like with the this and calling methods. So transformation from a lambda expression, from an anonymous inner class into lambda expression is not something that can be done without any kind of sense or a little bit brain power. You have to be careful. And capturing variables, they do define effectively final variables. One language feature which is very amazing, and this is changing, this is at least as important as lambda expressions by themselves. And they're called default and static interface methods. These are two different concepts. They are solving the interface evolution problem. And there is one amazing book from a guy that is a chief, or I think it's still working on Oracle, on NetBeans platform. He wrote a book called Practical API Design. And what he said was basically that APIs are like stars. Once introduced, they stay with us forever. And this was really, really true up to Java 8, because you cannot really do intelligent interface evolution. What you could do is do nothing. You can't do any method into interface because you will be breaking implementations. There were some situations, even in the core JDK classes, by extension of interfaces, but that just leads to a situation where you have too many types on a type system perspective. Type explosion, it's called. What is part of the Java 8 is a thing called default methods. So remember when I talked that functional interfaces are interfaces that have a single abstract method, and the abstract is important exactly because of this one. Starting from Java 8, you are allowed to define not only abstract methods, but also default methods. Default is a new keyword, and also static methods as part of the interfaces. They were previously called virtual extension methods or defender methods. Now they are called default ones. And the thing that we would be able to do in Java 8 is to put some code into interfaces, finally. And there is a big difference between, there is a still big difference between interfaces and abstract classes. Their interfaces are not becoming traits, interfaces are not becoming abstract classes, they're just able to execute some code. This is effectively solving the interface evolution problem. And an example of this might be that historically from Java 1 to 2 we have support for collections. And there is a collection framework, there is a collection interface. We had some methods, but a lot of the methods are just missing there. One of the biggest advantages of using Groovy over Java initially was to add a lot of methods that were just missing. And you were able to call them directly on collections, which is not the case in Java. So we created a collections interface with a lot of helper methods. But that forces you to call some methods on the collection by itself, some methods using some helper classes, which is kind of weird. And you have to know that sort is part of the collections, but the others are in the collection itself. By using default methods, this will solve the problem, together with static interface methods. So the second addition into the model in the Java programming language is that you will be able to define static methods. And if you are wondering, why would you ever put a static method into an interface? It doesn't make any sense. When I first looked at this, it was just weird. It doesn't make any sense. Why would I do that? Interface was meant to be a contract, something that you can define which kind of types you are required because of the method signature, but also the contract, something that you cannot really handle by the API, on the API level, like invariance. The reason for this is because only those two features together really are solving the interface evolution problem. So we might consider, this is not the case currently, but if you have your APIs, you might consider transforming or copy-pasting, that's an amazing technique, methods from comparators or collections as a class into collection as an interface. They would be static. That's the first part of the problem. And the second part of the problem, because you are able to define default methods, default method could directly use it. So from Java 8, you might be using and calling all that very nice method calls directly on collection interface, even if we do not define it before, and they are part of the other libraries. And one thing that I almost forget to say is that default methods are flexible. So it will be kind of unnatural to just forces everyone that implements an interface to use the default implementation that would look like kind of an abstract class. You are defining a default method as part of the interface, but any implementation could just change it to be more flexible. So you might imagine an iterator interface which has next and has next methods, and it might be kind of useful to have a skip method. You would just provide an argument of int, how many elements should be skipped. This was not possible up to Java 8. In Java 8, you would just define a default method that will iterate n times over the next, asking for has next, and that would be the implementation. And IRL list, because it has a different implementation, would just override it to use an increment the index. So it is just better. It is flexible, it's solving the problem, and those two together are very, very flexible. We are no longer paying that pain anymore. I will be not talking about Stream API because Tomasz will handle Stream API, so I'll just skip it. And because we have a few more minutes, I will just very quickly talk about performance. That's the last thing. And every time there is an addition into the programming language, people would start asking about performance. If the performance of Lambda expressions were so much slower than anonymous inner classes, people will literally not use it anymore. And so people start writing benchmarks. People don't know how to write benchmark because it's very, very hard to do. And comparing anonymous inner classes into Lambda expressions is a very bad idea. It just doesn't make that much sense at all. Because in terms of Lambda expressions, you are paying a different penalty. Every time you create an anonymous inner class, it will actually, if you ever wondered why on class path you sometimes have like a class name appended by a $ and a number, this is how Java-C compiler treats anonymous inner classes. Every time you use anonymous inner class, it will actually effectively generate a new class. By that definition, it's obvious that every time you create a new instance, you, well, at least at the first time, you are paying the penalty of class loading. It has to be loaded, it has to be verified, and there are other parts of the class loading mechanism. Because of concurrency, it has to be thread safe. And because this is by definition almost always class loading involves I/O, it's very slow, at least for the first time. In terms of Lambda expressions, it defines on the compilation technique. It's not, historically the very first proposals were really kind of transforming Lambda expressions into anonymous inner class. This is no longer the case. They are using a language feature that were added in the Java language, not for the purpose of Java language, invoke dynamic. So it's basically using invoke dynamic together with other invocations. So then we are paying the penalty because of the linkage. Where do we, what do we really want to invoke? And there are some other differences that are not that important. What is great part is that if you look at some of the benchmarks made by Oracle guys, those are the guys that should know what they are testing, and they do know, is that in some of the versions of the builds of the JDK 8, they were increasing performance mostly about Java Lambda linkage. This is the biggest pain point in using Lambda expressions. And just in like free versions, they increased the performance about 20%, which is amazing. And the performance was not the goal one of using Lambda expressions. The goal one was to be able actually to use them in a normal way. So there would be updated releases that will improve the performance even more. So what it basically means, practically speaking, is that you don't have to care about performance because it's right now it's comparable or even better, and it will be even better. There are some links that you might visit after the talk. If we have any questions, or if we have time for questions, anyway, we can handle questions after the talk or during the break. So that's from the Project Lambda from myself. Thank you.